Okay, so as in the last video we discussed about the statement of Rault's law. What did he say? He said that in a solution, the vapor pressure of each component is directly proportional to the mole fraction of that component, right? Then we derived it mathematically as well, that the partial pressure of A would be equal or would be directly proportional to the mole fraction of that component, right? So we are going to take vapor pressure or partial vapor pressure of A component, so that partial pressure of A component would be directly proportional to the mole fraction of A component, right? And then when we removed proportionality sign, we got is equal to sign, and along with the is equal to sign we got constant, which is P naught of A, right? Here P naught of A represents pure vapor pressure of A, which means nothing is mixed with vapor pressure of A yet, but that's why it is called pure vapor pressure of A, right? Then we discussed that partial vapor pressure of B is directly proportional to the mole fraction of B, and when we removed proportionality sign, we got is equal to sign and constant P naught of B, which is pure vapor pressure of B. Alright, today we will gonna apply the Dalton's law in it, and we will be finding the total vapor pressure of the container, right? Initially I mentioned that here we have a container in which only A's molecules are present, right? So it will have pure vapor pressure of A, which means P naught of A, pure vapor pressure of A. It is mixed with container B, which has molecules B only, right? And it has pure vapor pressure of B. We mixed them together. Still they have pure vapor pressure of A and pure vapor pressure of B. But when we mixed them both together, now we have A and B together, right? So now they'll not have pure vapor pressure. However, this A component will have its vapor pressure. This would not be pure since it is mixed with B component now, right? And this one will have vapor pressure, right? This would not be P naught of A, however only PA, which is vapor pressure of A, and PB, which is vapor pressure of B. Now we are going to find the total vapor pressure of it, total vapor pressure of this container, total vapor pressure. See here, the A vapor pressure or the B vapor pressure would not be decreased since both substances are volatile, right? A is volatile as well as B is volatile, means both have the ability to create the vapor pressure, right? So we have their partial vapor pressures. We don't have their pure vapor pressure, since when we were mixing them together they had their pure vapor pressure, but after getting mixed with each other they got their partial vapor pressures, right? So now we need to find the total vapor pressure, and that we will be finding, of course, the total vapor pressure is equal to PA plus PB, right? The partial pressure of A plus partial pressure of B, if we're gonna add them both together, we're gonna have total vapor pressure of the container, right? And this is what we call the John-Dalton's law. This is what we call the John-Dalton's law. Initially we applied this John-Dalton's law on the gases, right? When if there was a gas in the container and we mixed that gas with another gas, so now it will not have its pressure, now it will have a partial pressure, right? For example, air is a mixture of gases, right? This is air, for example, and air is a mixture of gases, everyone knows. Mixture of gases, right? It has nitrogen with it, nitrogen, oxygen, wait, helium or carbon dioxide, right? Now see, air is a mixture of a lot of gases, but here I have taken three most common gases, right? Nitrogen, carbon dioxide and oxygen gas. Okay, so now nitrogen will of course gonna have its own pressure, but in this container, if this container is a air, in this container the nitrogen will not have a pressure, but it will gonna have partial pressure. Since this gas is mixed with other gases, we'll not talk about oxygen's pressure, we'll talk about its partial pressure. This mechanism is going on in our body as well, the partial pressure in the respiratory system. Okay, uh, during the exchangement of the gases between alveoli, alveoli and the blood streams. So carbon dioxide, we're not going to talk about here carbon dioxide's pressure, we're going to talk about here carbon dioxide's partial pressure. Okay, so oxygen's partial pressure, nitrogen's partial pressure and carbon dioxide pressure. And if I do ask you what is the total uh, pressure of this container, so total pressure of this container would be what? The partial pressure of carbon dioxide, the partial pressure of oxygen, the partial pressure of nitrogen. Okay, and this law was given by John Dalton. Means total pressure of any component would be equal to the partial pressure of the components present in that component. John Dalton's law. And this is what we applied here as well during the partial vapor pressure, right? Now partial vapor pressure of A, we have already derived the equation, right? Pure vapor pressure of A into mole fraction of A. So let's write this here. Total vapor pressure is equal to P naught of A, which is pure vapor pressure of A, into mole fraction of A plus P naught of B into mole fraction of B. This is the final equation we got after applying Raoult's law, John Dalton's law, right? So total vapor pressure of the container, if we have taken volatile substance and volatile substance, means we have mixed two volatile substances together. A is the volatile, B is volatile as well. When we mix them both together, then how we're gonna have total vapor pressure of that container? Total vapor pressure of that container would be equal to multiplying the pure vapor pressure of A by its mole fraction, with that add to the pure vapor pressure of B into mole fraction of B. This is how you find the vapor pressure, the total vapor pressure of the container, by adding the partial pressure of the components present in that container. And partial pressure we have already found how we're gonna find, right? So this was all for today. In today's video we have discussed a lot and everything was very interesting, right? We found total vapor pressure, we found initially partial vapor pressure, pure vapor pressure, right? All the terms are very interesting. In the next video, now see, we have mixed volatile with volatile, right? In the next video we're gonna mix non-volatile with volatile, and then we're gonna find the partial pressure, the total vapor pressure, right? Afterwards we're gonna study ideal solution, non-ideal solution, elevation in the boiling point, depression and freezing point. We're gonna study each and everything in very detail. So this was all for today.